Okay, this is going to be a sequence and series like sample test. This is different than the other Algebra 2 sample test. This is something that was made in 2018, 2019 year. This is more probably closer to the actual test for this. Okay, there are some formulas that you're going to have, so you can go ahead and write these down. The arithmetic formula is this, and the geo formula is this. These are formulas that you will be given, okay, for your test and quiz. So I have written them down for you for this, okay. Arithmetic, the big thing is the pattern is addition and subtraction. For geometric, the pattern is multiplication. Okay. The other big thing with geometric is the R. Okay, so it's multiplication, but the R will be the second term divided by the first. That's probably the biggest things you have to know as we go through this. So the next four terms consider an arithmetic sequence. A1 is 30, A2 is 17. So that means the common difference here would be negative 13. If I were to look at what the next terms would be, all right, I have 30 and 17, and then I would subtract 13, which would give me 4. Subtract 13 would give me negative 9. Subtract 13 would give me negative 22. The explicit formula, the only things you have to fill in for the explicit are the A1 and the D, the difference. So what you're going to have here in this one would be AN equals, the A1 is the first term, 30. Plus n minus 1, where the difference is negative 13. Okay. For the recursive formula, okay, for the recursive formula, you write A1 equals, all right, which A1 in this case would be 30. And then I got AN equals AN minus 1, where the recursive, I just put the pattern, so whatever your pattern is goes right there, of minus 13. Okay? Move this up. Okay, next four concern arithmetic. Okay, now in this case, the difference here, make sure you can see that, I think you can, yep, will be a positive 15. So the next three terms, I got 8, 23, and I would add 15, so it'd be 38, 53, 68. The explicit formula for arithmetic, AN equals, A1 is 8, N minus 1, where the difference is 15. If I write the recursive formula, A1 is 8, AN equals AN minus 1 plus 15. Okay? All you got to do is write the pattern. Okay? Moving on. Okay? Geometric formula. Okay? Write the next three terms in the sequence. Okay? So A1 is 60. Now the pattern is going to be multiplication. So what I'm going to do is 60 times 0.5. Would give me 30. 30 times 0.5 would give me 15. And 15 times 0.5 would give me 7.5. Okay? Write the recursive formula for this. Okay, recursive would be A1 equals 60. AN equals AN minus 1 times 0.5. Okay? Write the explicit. Explicit formula would be A1 would be 60. My R would be 0.5 to the n minus 1. Okay? Now, this says find the sum. When you find the sum, okay, of anything, you're going to use the E thing. Okay? All right? Sn, the sum, all that stuff. What you do is you put n equals 1 down here. The number of terms goes here. Your explicit formula, all right, explicit formula goes here. Okay? All right, everybody was pretty good in that in class. All right, so for this example, I go to Option, Calc, scroll on F6, all right, E3. My formula goes in first. My formula would be 60 times 0.5, exponent, alpha, n, minus 1. Then I hit over, and it drops down to that, alpha n, 1. Now the number of terms here is 10. So that's what I put there. And my answer is 1198.88. Okay, moving on. Okay, same deal. All right, next three terms. I would start with 5, 3 blank spots. All right, and I would do 5 times 3, 15 times 3, 45 times 3, 135. Okay, write the recursive formula. That would be A1 equals my first term, AN equals AN minus 1 times 3. Okay, this is multiplication. Write the explicit. The explicit would be AN equals, A1 would be 5, my rate would be 3 to the n minus 4. They're asking for the sum, so that means that I would use this. I use the explicit formula, 5 times 3, exponent, alpha n minus 1, alpha n, whoops, that's h, alpha n, 1, and then in this case they want me to find 14 terms, so 14 goes here, which would be 119,574, 20. Okay? All right? Moving on. Okay? Now, all right, here's the difference. When they tell me to find this term, what that means is I sub that number in for n. Okay? Now, if they give me the formula, fantastic. If they don't give me the formula, I got to make it. So in this case, it's pretty easy because they give me the formula. So I do 8, parentheses, 5, exponent, and I'm going to put 16 for n. Okay? All right? And that would be that term. Okay? All right? 2.4 E11. Okay? If you get above 10, usually, all right, that's probably not a great question. All right? Usually the number will be a little bit more reasonable. Okay? Find the 11th term. Okay? Find the 11th term of this. All right? 24, parentheses, exponent, 1/2. Exponent, now I want to put 11 for n. Okay, 3 over 128. That's pretty easy. Okay, all right, these are just the E questions. All right, the big thing is if they give you the parentheses, you got to put them all in. So I see parentheses there, so parentheses 2, alpha k, plus 7, close them. As you can see, I have a double set, but that's the way you should do it. Alpha k. Okay, now they tell me I want me to start at 5 here, so I'm going to go 5, and I'm going to end at 11. So follow what they give you on that. So that answer would be 161. Okay, find the sum of this one, E, okay, parentheses 3, alpha k, minus 5, close them. Okay, alpha k is going to be 3, and I'm going to go to 7 this time. 50. Okay? Moving on. Okay? All right, now when you have infinity, what you should do is use 100 for that top number. Okay? All right? So I'm going to do E, 12 parentheses, 1 over 3, extra parentheses, exponent alpha n minus 1 over alpha n 1 over 100. Okay? If I do that, calculates, I get 18 for an answer. Okay? Now I'm going to go ahead and do this one. 2 parentheses 6, exponent alpha n minus 1, alpha n 1. Alright, and then I'm going to use 100. Now watch what happens on this one. So you see I get a really big number there. That means this one's going to be no sum. And we'll talk about that one a little bit later. Okay? Alright, now find the sum. Once again, find the sum, 60 terms. Now, what I have to do is make the formula. Well, if I look at the pattern there, that's going to be add 6. Alright, so that means I'm arithmetic. So my formula would be 7 plus n minus 1, okay, times 6. Okay? So I got to make that, alright, oops, come on back. All right. So here, all right, 7 plus parentheses alpha n minus 1. All right, 6. All right. Alpha n 1. All right, 60 terms. 6D. All right, so that's going to be 11040. All right, now on this one, find the sum of the first 35. This difference would be a -4. So my formula would look like this: 28 plus n minus 1, -4. Okay? All right, 28 plus parentheses alpha n minus 1, close them, -4, close them. All right, alpha n 1. Now here they want me to find 35. So that's -1400. Be my answer. Find the sum of the first 50. Now what's nice is they made the formula for me. So this is even an easier problem than before. Oh, oops, I forgot the E. 4 plus alpha n minus 1, -2, close them, alpha n 1, and then they want 50 terms. So -2250. Okay? Now we're going to move into probably the most challenging problems. These two are the most challenging problems of this whole sample test. Okay? All right? Now, we need to find the sum. Oops. Okay. We want that to happen. Okay. We want to find the sum. The problem is, when I go to the E thing, I would make my formula. This would be +4. All right, which I'm going to need the formula. All right. The problem is, when I go to E, I have no idea what that top number is. So what I'm going to have to do is I'm going to have to guess numbers to figure out which one gives me 54. Now, there's no right way to guess. I like to start out by putting 10 in for n all the time and just see what I get. Okay? I get 46, which is not enough. So I'm going to need to get to 54. So let me try 15. All right, 15 minus 1 with 4. Let's see where that puts me. Okay, a little bit too much. Let's try 13. Okay, still too much. Let's try 12. Okay, now, as you can see, that matches up. So the number of terms is 12. So when I go into the E thing now, I would put the formula as 10 plus, parentheses, alpha, n minus 1, and then the 4. Still n 1 down here. And that number that I finally figured out, that when I guessed I would get that goes for right there. It's 12. So it's 384. Okay? Now, if I look, same thing on this one. Pattern here, though, is -8. So my formula would be an equals 72 plus n minus 1. And then -8. Now, what I want to do is I want to substitute in, and I want to get 8. All right, that's got to be the number of terms, because I don't have that. Okay, so let's try 10. I like using 10 to start with. It's usually a pretty good barometer. Okay, that's too much actually. All right, that's too much. All right, so I'm going to go a little bit less. Let's go 9. Let's go 8. 8 minus 1. And -8. Okay, too much. I think I got to go 9. 9 minus 1, -8. And that matches. So my number of terms is 9. When I go into E now, I can use that formula I've been using. 72 plus parentheses alpha n minus 1, -8. I'm using 9 terms. Like I said, those are probably the hardest problems in this whole thing. Okay? Moving on to these means problems. Okay? Find 4 arithmetic means. Now, when you have arithmetic, okay, and all right, 4, that means I've got 4 spaces between that number. Now, when it's arithmetic, what I want to do is subtract big from small. Okay, I'm going to subtract big from small. All right? And what I'm going to do with arithmetic, so with arithmetic means I'm going to subtract big, small, or big minus small, and then I'm going to divide by n minus 1, which n stands for the number of terms. I've got 1, 2, 3, 4, 5, 6 terms. So in this one, it would be 6 minus 1, which would be 5. So I'm going to divide 45 by 5. So what this gives me is it gives me the pattern. Okay? The pattern is add 9. Now this is where you have to have a little bit of number sense. If I want to go from a small number to a big number, I would add. So I'm going to go 18 plus 9 would be 27, 36, 45, 50, 54, 63. Okay? If it was flipped, okay, then I would just go small to big the other way. Like this one. I would do 84, well, hold on, let's figure it out. Find 5 terms, so 1, 2, 3, 4, 5, and then my number. I'm going to do 84 minus 30, which gives me 54, and I'm going to divide by n minus 1. Okay, so I got 1, 2, 3, 4, 5, 6, 7, so 7 minus 1 would be 6. So 54 divided by 6 is also 9, I believe. Yep. So now, I wouldn't add 9 this way because it would go too big. I would add 9 that way. Or you could subtract, either way. But 30 and 9 would be 39. That would be 48. That would be 57. That would be 66. That would be 75 and 84. If I subtracted 9 that way, it would work as well. Okay? Now, the next 2 involve geometric sequences. Okay? So now, you have 2 means there. Okay? Now what I'm going to do with geo is I'm going to do big divided by small, a little bit different. Okay? And then what I'm going to do is whatever, I'm going to take the root of that number, and the root is going to be n minus 1. So what I would do is I would do 432, okay, divided by negative 2. Or 432 divided by negative 2. Okay? And then I'm going to take, all right, if I count the number of terms, 1, 2, 3, and 4, so that's 4 minus 1. So I'm going to do the cube root of negative 216. Now, I would caution you, when you do negative cube roots, okay, all right, if you're, for some reason you get a crazy answer, make sure that your complex mode is set in real, okay? All right, so if I do that, I get negative 6. So negative 6 is the multiplication pattern. So negative 2 times negative 6 would be 12. 12 times negative 6 would be negative 72. And if you multiply that, you get that one. Okay? Now on this one, I'm still going to do big divided by small. So I'm going to do 800 divided by 12.5. Which gives me 64. Now, I've got 1, 2, 3, 4 terms. So 4 minus 1 would be 3. So I'm going to do, once again, the cube root of 64, which is a pattern of 4. Now, once again, use logic. If I multiply that by 4, it wouldn't get to that. So I'm going to go the other way. I'm going to do 12.5 times 4, which is 50. 50 times 4 would be 200. 200 times 4 would give me that. Okay? I think we're moving to the last page. Okay? The 5th term of the arithmetic sequence is 25. The 8th term is 43. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So, what you do here is you pretend like this part's the only part that matters, and I'm doing an arithmetic sequence. So I'm going to do 43 minus 25, which will give me 18. I'm going to divide by n minus 1. Well, if I count the terms, 1, 2, 3, and 4, 4 minus 1 would be 3. 16 divided by 3 would be 6. So that'd be 31, 37, 43. Now, if I add 6 this way, I would subtract 6 this way. So subtracting would be this way, Adding would be this way. So if I subtract 6, it'd be 19, 13, 7, 1. Okay? All right? These are some more arithmetic recursive problems. Find that. This is just a recursive formula, which means I'd start with this. This is my pattern. That is my pattern. So I'm going to add 7. That would be 12. Add 7, 19. Add 7, 26. Okay? On this one, I want to find the 7th term. So I got 6. Now, this pattern means multiplied by 4. So 6 times 4 would be 24. 24 times 4 would be 96. So I'm on my 3rd. Times 4 would be 384. That's my 4th term. 384 times 4 is 1536. That's my 5th. Times 4 is my 6th. And then times 4, the 7th term would be 24,576. So 24,576. Okay? We've got a couple left. Okay? I've got this word problem about dropping from a vertical height we went through in class. All right, the bottom line here is the thing, this is going to be your pattern. Your pattern is going to be a multiplication of the bounce. Now, what most people make the mistake on with this is the 50, 3, 4. It's not 4 because this doesn't count as a bounce. The first bounce actually is here. So what I'm going to need is I'm going to need an extra term. So I'm going to take 50 times by a 5th. Okay, which is 10. All right, 10 times a 5th is 2. 2 times a 5th is 2 fifths. 2 fifths times a 5th is 2 over 25 times a 5th is 2 over 125. So that would be my answer. Okay, last problem. The following are infinite series. Okay? Alright, so basically what we would do if it's an infinite series is we're going to do all problems like this. These are all going to be geometric ones. Okay? There's two ways really to do it. I'm going to show you the calculator way. I think we'll have more success with that. What you need to do, the big thing is you got to find the rate in all of these. Okay? As a reminder, rate is second divided by first. Alright? So this first one, I would divide 6 by 3. I'm just going to get all the rates because I think this will be faster. This rate will be 2. Okay? 25 over 50. This rate will be a half. Okay? 64 over 192. This rate would be 1/3. 40 over 8 would be 5. Okay, negative 72 over 216 is negative 1/3. And then negative 15 over 3 is negative 5. Okay, now, if you look at the rates, if you took the absolute value, anything less than 1 would be a sum. So this would be a sum, this would be a sum, this would be a sum. These are not going to be, okay? So there's two ways of doing it. If you take the absolute value, if it's less than 1, it's a sum. Obviously, all other situations are no sum, all right? The other way you could do it is just put it into the calculator, E, all right? Show you a quick way of doing this. So this first one would be 3 times 2 to the alpha n minus 1. All right? And 100. All right? As you can see, that's a big one there, so I would have no sum for this. First one would be no. All right? No sum. Okay? All right? No sum. All right? Now this next one, if you want to just go back in, this might save you a little bit of time. If you go back in here and just change these up. First term now would be 50. Second term would be a half. That's not going to work. You basically got to change the formula. Times a half, exponent. Why that's not working? As you can see now, it would change to a sum, so it would be a sum there. All right, then I go into this one. I just change the formula. Okay, so that would be 192 to start, times, my rate would be 1/3. $288, so this one have a sum. Okay. Go into this one. All right, now I make the rate for this one 5, so that would be 8 times 5 to the n minus 1. As you can see, big E there, so that's no sum. All right, now we'll do this one. So you can either do the way I'm doing it or know the principle. Either way doesn't matter. $162, so that would have a sum. And if you try this last one, all right, negative 3 times negative 5 to the n minus 1. As you can see there, big E there. Like I said, the other way of doing it is this isn't less than 1, no sum. This is less than 1 sum. This is less than 1 sum. 5 is not less than sum, no sum. Now this one's a sum because if you do absolute value, that negative third becomes positive, and this would also be no sum. So either way you can do it is fine. This should help you a lot on the test.